Hello friends, in this video we will try to identify critical path in a schedule network diagram, and we will also calculate floats. So let us take a simple example to understand the critical path. So take an example of an IT project where we have a small requirement which we want to baseline at a one go, and after that there are two components need to be developed out of that requirement. They can happen in parallel, and after that they need to be integrated and delivered. So the same thing, if I plot it in an activity diagram method or in a network diagram method, it will look like this. So we have a first activity which is requirement gathering. So we have a requirement analysis or requirement gathering activity which will take 2 days. Once we are done with the requirement, we can start both the modules in parallel, and these modules will have activity for design and development, and here also we will have an activity for design and development. Now we can say that this design and development is happening for module A, and this design and development is happening for module B. Module A is relatively a complex module, so designing and developing a module A will take 5 days, and the module 2 is relatively simple, so it can be done in 3 days. Once you are done with the design and development, you perform testing, a module level or a component level testing. In both the scenarios you will do module level or a component level testing, and testing takes for this module it takes 3 days, and for this it takes 2 days. Once we are done with the testing, we do an integration of these two modules, and an integration activity takes again 2 days. So we do an integration, and after that we just release it, and releasing will take 1 day. Now we need to identify the longest path in this schedule network diagram, because the longest path represents the critical path. So how many paths do we have in this diagram? We have 2 paths. One path is this one, and another path is this one. Now we can just visualize and see the total duration of both the paths, because the network diagram is relatively simple. It looks like 2 plus 5, 7, 7 plus 3, 2 plus 5, 7, 7 plus 3, 10, 10 plus 2, 12 plus 1, 13. So the path length of upper path length is 13 days. And let us look at the second path, which is 2 plus 3, 5, 5 plus 2, 7, 7 plus 2, 9, 9 plus 1, 10. So we have a 10 days. What does it represent? It represents that this particular project cannot be finished in less than 13 days. And any of these activity, if get delayed, it will increase the duration from 13 days. And that is the definition of critical path. Critical path is the longest path of a project schedule network diagram, and the critical path gives us a minimum duration for a project to finish. And any activity on a critical path, if it get delays, it delays the complete project, because on a critical path we do not have any float. Now I use the term float. Float also used as a slack and float are synonyms, and float is also termed as a total float. Float represent the amount of slack we have in an activity without delaying the complete project. Now since this path of an activity has a slack, because the total path duration is 10 days, if I delay this particular activity by 1 day, at the place of taking 2 days, if this testing takes 3 days, my project end date does not get impacted because this activity was not on critical path. Since this diagram is simple, we can easily identify the slack just by knowing that the critical path is 13 days, this is 10 days, so most probably we will have a slack of 3 days. But in general, the network diagrams are not that simple. So in order to identify a slack, we need to do a forward pass and backward pass. What is the forward pass? We can visualize a one activity box. We would be plotting it for all, that for every activity we calculate by forward pass early start and early finish time. So when we go forward, we calculate these two numbers. When we come backward, we calculate late finish and late start. So what does the late finish and late start means? Late finish and late start without impacting the project duration means how late I can finish this activity without impacting the project duration. For example, how late I can start the testing of module 2 without impacting the 13 days timeline. And that is a definition of slack. So slack is a difference between late finish minus early finish, or a difference between late start minus early start. So if you have a number here, means if you have a different early finish and late finish time or a days in a given activity, it represents you have slack there. For the activities which are on critical path, we will have zero slack. So let us calculate the forward pass and backward pass for this schedule network diagram. Since the first activity is 2 days, so here we need to put an early start. So early start is day 1 and early finish is day 2. So how do we calculate early finish? By adding the early start plus duration, which is a duration of this activity, minus 1. So in this particular example, 1 plus 2, 3 minus 1, the 2, the end date. So it will take 2 days, and on the end of the day 2, this activity is done. Now, since the designing of module 1 and designing of module 2 is dependent on requirement baselining, they cannot start till the time this activity is finished. Since we are talking about early start time, so we need to see the previous activity's early finish time. So this early finish time is 2 days. So this particular activity cannot start, both these activities cannot start before the day 3. So here our early start day for these two activities is 3. How it came? The early finish date of a preceding activity plus 1. So it is finishing on day 2, they both can start on day 3. Now we need to identify early finish, which is again simple. Early start plus duration minus 1. 3 plus 5, 8 minus 1, 7. Now if you find this minus 1 plus 1 tricky, you can simply look, say, the early finish date of a previous activity plus duration also gives you a 7 number. But it's better to keep simple rule, and this formula is simple enough. Now this activity is finished on day 7, and this activity is only dependent on this particular activity. It can start on day 8 plus 1. And this activity, early finish date for this activity would be 8 plus 3 minus 1, which is 10. 8 plus 3, 11, 11 minus 1, 10. Now here we need to stop because we have not yet calculated the early finish date for testing activity 2. So let us come to the path 2 and calculate the finish times. So early finish for design and development of module B is 3 plus 3 minus 1, which is 5. Early start for the testing of module 2 is 5 plus 1, 6. And early finish for testing of module 2 is 6 plus 2, 8 minus 1, 7. Now, the integration can only start once the testing of both the modules are done. Now, here we have early finish of 10 days and here we have early finish of 7 days. When we are going forward pass, we take the maximum of early finish. Why? Because this activity cannot start till the time both the outputs are available. I cannot start on day 7 because I need this particular input. I also need a module 2. I cannot integrate just module 1. So I have to take maximum of it because both the inputs are necessary. So for integration, my early start would be day 11. 10 plus 1. I have to take maximum of these two. So on 11th day, I will start, and since I have a 2, 12, 13, minus 1, on day 12, I will finish. The release is starting on day 13 and finishing on day 13 because only the 1 day duration. So 13 plus 1 minus 1 is equal to 13. So you see that the 13 is matching with your critical path duration. So by doing a forward pass, you end up identifying a critical path duration, and you also identify, in order to identify the float, we need to do a backward pass. Now what is backward pass? Since release is our final activity, for this particular activity, early start and late start would be same, because if this activity get delayed, project will get delayed. And the difference, we can only have a different early start and early finish, early start and late start once when we can do a late start without delaying a project. Since it's the last activity, our early start and late start has to be same, and our early finish and late finish also has to be same. In order to finish project in 13 days, release must happen on day 13. Now in a backward pass, we take the late start date and move it to late finish date. Now when we are going backward, we need to copy the late start and minus 1 to identify the late finish. So it is 13 minus 1, because when we were going forward, we were picking the early finish plus 1. Here we pick, rather than plus, we are focusing on subtraction. So 13 minus 1 gives us a late finish of 12 days. And 12 minus the duration. So 12 minus the duration plus 1 gives us the late start time. So let me write this formula here because you may find it a bit confusing. So late start is late finish minus duration plus 1. So in this particular case, 12 minus 2, 10, and plus 1, 11. So early finish was calculated using early start plus duration minus 1, and late start is getting calculated. So here we were calculating early finish. Now here we are calculating late start. Late finish minus the duration plus 1. So we got 11 as a late start for integration activities. So you will see, you see that for an integration activity, the late start and early start. So late start and early start both are the same because they are on critical path. So activities which are on critical path will have zero float. Means for them, their early start and late start would be the same. They do not have any flexibility. If they delay, project get delays. So let's look backward, and here we have a confusion again. We have two activities and we have 11 as a number. Now this 11 goes here as well as here. Now 11 minus 1, since we are going backward, we need to do a minus 1. So the testing of module 2 should finish by day 10, and testing of module B should also finish by day 10, because the late start of integration is 11. So by latest, this integration activity can start on day 11. So both the activities must finish by day 10. Now late start for testing of module B is calculated 10 minus 2 plus 1, which would be 8 plus 1. Nine. So 9 becomes the late start for activity test module B. Here 10 minus 3, 7 plus 1, 8. See, you can see that both are coming same. It represents this path is critical path, which we also identified initially, but it is also getting proved that since we do not have slack here. Now this late start get moved here with minus 1. So this activity must finish by day 8, because this activity can only, the latest it can start on day 9. 8 minus 3 plus 1 represents 10. So this activity must start on 8 minus 3 plus 1. I reversed it. It represents 6. So this activity must start on day 6. Latest by day 6. Here, let us look since it's a critical path, now you can also just copy it, because they are going to be same. And since here if you have late start of 3 and late start of 5, you have to take minimum, because this activity can latest by start by 3. So when we were going forward, we were taking maximum when there were path conversions. When we are going backward, we need to take minimum, because the latest this can finish by to satisfy this activity. So this activity must finish by day 2, then only I can start this on day 3. So minimum of these two will drive the late finish of activity requirement analysis. Now we have calculated early start, early finish of the complete network diagram, and we have calculated late start and late finish of the complete network diagram. The difference between the late finish and early finish represents the float. So we have 3 days of float for this activity, and we also have a 3 days of float for this activity. This particular path, the total float, the slack this particular path has is 3 days. So any of these two activity can delay by 3 days without delaying the integration activity, because integration activity will start on day 11 only. Even if they finish on day 7, which is their early finish, there would be a waiting, because the integration can only happen when these two modules are available. So this is what represent slack. Now this is another term, a total slack and or a total float or a free float. Free float is a term which represents a particular activity can be delayed without impacting anything, any of the other activities. So for example, if I am delaying this activity by 2 days, I am not delaying the project, because anyway I have a 3 days slack in this particular path, but delaying this activity for 2 days will delay the testing of component 2. So the second activity is getting impacted even though it is not on critical path, and the impact is I need to communicate. So if I want to delay this, I need to communicate the resources who are sitting here that hey guys, I'm going to delay this, so you plan something else for your 2 days. The free float, where you don't have to inform anyone, means if I delay this particular activity by 3 days, I don't have to inform anyone, because anyway this particular activity will start on day 11 only. So the delay in this activity is not impacting any other activity. So if you have that kind of flexibility, it is called free float, and a float or a slack at a level of a path is called total float. And this is how you can calculate the critical path and floats or slacks using forward pass and backward pass. I hope this video will help you in demystifying critical path method.